We have not gone through convolutional neural networks. This neural network is one of the most used one in real life. For example, these cars, and also in OpenCV we can see, and we based on the pictures, we wait from the algorithm or application to find out what kind of material or what kind of picture that one is. In this tutorial, I find a good data set, cats and dogs. Uh, there are more than 10,000 different kinds of cats and dogs. We will train our convolutional neural networks, but beforehand we have to create and build up our neural networks. And I will in this tutorial I will show you step by step how we can build up a convolutional neural network, and after that we will make some predictions in order to evaluate the performance of our algorithm. Yes, shortly the lecturer has been delivered his lectures about convolutional neural networks, but I will touch on a little bit about how it works. And I found a picture. Based on the picture, different people can see different image, right? For example, if we see this picture deliberately, if you focus on, if your brain is focused on here, you will see a young lady, right? As you can see, this is her eyes, this is her nose and ears and her black hair, okay? And but if you focus on a little bit, you can also maybe some of them, or firstly find out there is an old lady here. This is her scarf of the old lady, and this is the hairs of the old lady, and this is the nose, and this is the mouth, and this is the eyes, okay? So our brain detect the images according to the features of the image, okay? And even our brains sometimes make some failures. And let's look at this image again. This is another picture. Of course, after we look the image a couple of seconds, we easily understand there are two different images here. One of them is if you one side are nose and mouth. This is one option. The other option is the half of the head of someone, right? This is the iris. So our brains is maybe a little bit complicated with these kinds of images, right? And this is also a case for the convolutional neural networks, because the convolutional neural networks is also making its predictions about the images according to the features of the image. Okay, I found a trained convolutional neural network results. In the first picture, you can see a cheetah, right? It is very easy, and our brain detect easily that it is a cheetah, right? And also, it is also a case for the algorithm. As you can see, this red line shows the percentage of the algorithm prediction. Algorithm almost more than 90% say that it's a cheetah, and very maybe 2% leopard, or maybe 1% snowboard and Egyptian cat. Okay, based on the feeds of the animal pictures, the algorithm easily detects that this is a cheetah because it's a very clear picture for both our brains and for also a machine learning algorithm. Okay, but this picture or image in the middle, it is a little bit complicated, right? Because we see a train station, we can see buildings, railway, and also we can see a train. But as you can see, the prediction of the algorithm a little bit fewer than previous one because it's a little bit complicated picture. There are a lot of features that algorithm should have to deal with, and this number of features affect the performance of the or the clarity of the picture affect the performance of the both our brains and also our convolutional network algorithm. And maybe 90% he said it's a bullet train. It's right, yes. And maybe 5% passenger car and subtrain and electric locomotive. Based on the feeds of the pictures, the performance of the algorithm is also very good for this picture in the middle. And when we come to the right picture, even I don't know what this one is, right? We can say that this is a scissor, okay? Maybe it is a hand glass. Maybe someone think that it is a frying pan to make eggs. Yes, it's possible. Maybe someone think that if someone is a doctor or an educational background from health, maybe you can make this one similar to the stethoscope. Yes, it's possible, right? Now we are also very complicated. Even I don't know what this one is. Both of these options are possible for this picture, right? And for this picture, this is these are the predictions of the machine learning algorithm. It says that the first prediction, almost 90%, it says that scissors, and this one, the possibility of hand glass for the algorithm, frying pan, and stethoscope. So, like we become very complicated. Our brain is become very complicated to determine what kinds of image, what kinds of material this one is. This is also the case for the algorithm. So all of the things we have to get from these pictures, that convolution neural networks, all of the neural networks is very similar to our brains working. So when we detect an image or determine what kinds of material or animal image is, we look at the features of the animal. Even though we are not aware of it, our brain detects the features because we have seen a lot of cheetahs beforehand, so we know that it looks like cheetah. Okay, our brain easily detects this one is cheetah. But when the picture is a little complicated, even though our brains is cannot be able to predict accurately what this kinds of this one is a hand glass or stethoscope or frying pan. All of them are possible for my brain at least. So the main point here, the convolutional neural networks make its predictions according to the features of the images. Okay, but how convolutional neural networks can scan the images? Okay. We have to say that there are two options for the convolutional neural networks. If the image is white and black, okay, if image is white and black, as you can see here, or it is a colored image, it differentiates what kind of image it encounters, as we brain does. So in black and white images, it's a two-dimensional array. The computer neural networks assign two-dimensional array, and these pictures is represented by pixel in matrices. Okay, so what the algorithm does is we have to transform the pictures based on the colors into the pixels. The pixels, as you can see, this is a picture image, pixel version of picture representation of the image, and it has been divided into 4. Okay, each pixel represents the intensity of the color white or black, and the intensity is assigned from 0 to 255. Okay, so each these pixels represents intensity of the white or black from 0 to 255, and also it is the same for the next one, the same for the next one, for the same for the next one. So Basically, these white and black images is represented by two-dimensional matrices in pixels, which represent numbers from 1 or 255. Okay, so when it comes to colored images, all of the colors we see around the environment is a combination of red, yellow, and blue. Okay, so if the computer encounter or the algorithm encounter a colored image, it is represented by 3D array or matrix, because colored image is represented by mainly three main colors, mainly red one and the yellow one and then the blue one. Okay, it's also a case the density of the yellow one or the density of the green one or the density of the blue one is also represented by pixel. These colors has been assigned by numbers from 1 also to 255, as it was case for white and black pictures. Okay, so based on these numbers, for example, if for example 255, which means that very density of blue color, if it is represented by blue, it's very close to the for example 255, which means that the density of the blue color is very high. Okay, so so proportionally the density of the other colors will become very lower. And if the density of the red increase, and also the density of the other colors will decrease. So mainly we can say that the pictures is represented by numbers, by pixels, which includes matrices, which represent also colors from numbers from 1 to 255. Based on these numbers, based on these matrices, the computer understands that okay, it is a blue or it's a red or it's a yellow. Okay, so it is how the algorithm understands the pictures. It is a little bit different from how we understand in our brains, but we have to understand that all the pictures, all the colors is only represented by numbers in matrices, or in other words, in pixels. Okay, we understand that in a convolutional neural network, we get an input as an image. Okay, so the convolutional neural network assign first of all transform these images into numbers or into the pixels, which is represented by numbers or matrices, and after that assign some weights and biases in order to detect the features. I focus on features. In order to detect the features of the image, the algorithm assigns some weights and biases for this picture and train itself. And after that, it aims to differentiate from one picture to another one in order to, for example, if based on our inputs, if the picture is a cheetah or leopard or elephant, and etc. So the second thing, like we can mistakenly cannot correctly understand the image, and it is also the algorithm is also a case for the algorithm. So the algorithms also are prone to same mistaken categorization as we did if the image is very complicated, as I showed you previous pictures. So this is the this is the frame of how the neural networks works in codes. Okay, after transforming, this is the inputs. There will be some kinds of pictures or materials. Okay, And these materials or pictures will be transformed into the pixels or matrices. This will become our input layer, okay? This will be our output layer, but based on the output layer, we will have some classes. If, for example, in this tutorial, I will focus on just two cats and dogs. So our classes will be class 1 or class 2, dog or cat. But in some cases, if we feed the algorithm a lot of animals, for example, 30 animals, the class will be 30. So this will be our output layer, okay? In order to determine the output layer, we use softmax function or sigmoid function. As you know, sigmoid function, I can show you a sigmoid function basically from let's see from here. Let's get a picture of it. As you can see, this is a sigmoid function, right? This one. It begins from 0 to 1. It's very good to binary classification problems. For example, in our case, it's a cat and dog. So if 0 is represented by cat and 1 represented by dog, so we can use sigmoid function for our output layer for our problem. But if it includes more than two classes, for example, elephant, zebra, dogs, cats, and etc., we have to use softmax function because it enables to make more classification for the algorithm. So this is the reason. This is the output layer. We mainly use. This is all people, all developers use two options. There is no other options, I think. Softmax function if we have more than 3 or 4 classification problem, and if we have 2 binary classification problem, and we use sigmoid function. And I explain why we use sigmoid function for binary classification, because it enables us to, it returns us to 0 and 1. So it's very suitable for classification, okay? So between our input layer and our output layer, we have a lot of we have some different layers when we compare to the normal artificial neural networks. We have a convolutional layer, which means that we will get the images, transform them into, after transforming them into the pixel, we will the algorithm will get this convolutional layer will get the features. What kinds of features this picture holds? Okay, and after that, we will use ReLU function for this layer in order to determine these features for the images. And after that, because the size of the images and the number of the images will very high in most cases, we have to simplify it. So by using max pooling, this will be our second layer. We will simplify the feature. We will use most significant features, because in other cases the working of the algorithm will be very slow. Okay, we will see later when we work on with the code. So the second layer will be max pooling, which means that simplifying the matrices coming from the convolution layer. And after that, we will create a flattening layer, which means that even though we simplify the images, we use very simplify the images, simplify matrices. By flattening layer, we will transform these very complex matrices into one-dimensional matrix. Flattening means converting these 2D or 3D or more dimensional matrices into one-dimensional matrices. It can be sound a little afraid. Wow, flattened, what does it mean? It just does converting two or three or four dimensional matrices into one dimensional. That's simple, is it? Because if we simplify from two-dimensional, two or three-dimensional matrices into one-dimensional matrices, we have learned from this semester mathematics. The matrix mathematical operation will be also simplified. So training process will be very simplified, and the mathematical matrix operation will be very simplified. Therefore, mainly we use also flattening layer. And after that, we create normal artificial neural networks and train our data and find out what kinds of class it should go to, class 1, class 2, class 3. Okay, this is very simple version of the how we should work with the convolutional neural networks. Have you got any question to this point? And yes, I know that this convolutional neural network a little bit complicated. Recurrent neural network and convolutional neural network a little bit complicated. But if you repeat these algorithms in the future, and you will see that it is not so complicated and you will either work with them with bytecode. Okay. Let's go to the coding if you don't have any questions. And this is all my theoretical explanation. And from this theoretical explanation, I will go to the how we can use this theoretical information into practice, how we can build up our convolutional neural network. So in these problems, mainly we use Python as a main programming language. So I will go to the Python, and you can use Jupyter Notebook to work with this this tutorial, or you can simply just watch it, or you can use Kaggle. I mainly use Kaggle because after I creating my code and I can publish it for my CV, it's very good. And also when I use Kaggle, it will not cost storage for my computer. Okay, so it will basically will save into the Kaggle, my Kaggle account. So when I want to reach them whenever I want by using internet, I can reach them instantly without leaving my computer. This is the reason why I use Kaggle. In Kaggle, this is in code section here. You can see after I clicking code, your work section will show you your algorithms. Okay, what kind of your work, and if you want to need a new notebook, just click on the new notebook section here. It will create you a new notebook, a new working space in your Kaggle account. One of the best one is you don't need to download or install any machine learning libraries. It is already predetermined in Kaggle account, so I will just simply import them and use them. Okay. You can name this one. Let's let that one say practice. Okay, practice 2, maybe. Yes, first of all, we have to run this first coding line. This is mainly we are importing NumPy, we are importing pandas. These are main pillars we're working with machine learning algorithms. So when it comes to deep learning, we have to use with TensorFlow library. This is the main library, TensorFlow library. There was 2 different libraries, TensorFlow and Keras, and now it has been, both of them has been combined as a one single library under the umbrella of the TensorFlow. So by importing TensorFlow, we can work with deep learning algorithms here. STF. I'm just importing TensorFlow STF. This is alias. Not important. You can use whatever you like. And first of all, the second we have to use. Let's come here. we have to add our data. Okay, I'm just clicking add data section here. You can add the data from your own computer or from internet or from Kaggle. Just click add. You can search here dataset from Kaggle here, or you can upload from your own computer here by uploading here. I will just say cat dog, and it's very famous. As you can see, there is a data set for DLE, which means deep learning model. Okay, I'm just clicking add. Now it will add this data set into my workspace, as you can see on the right. Okay, let's click on this. This cat and dog data set includes test data set and training data set. Let's click test data set, for example. As you can see, there are images of dogs and cats. It's also a case for my training data set. Let's click training data set, click another one, and these are in this file. The cats is stored in this file, in cats file, under this main file and or folder, and these are dogs. Let's click on it. As you can see, there are many cats here. Let's click one of them. You can see an image of a cat here. Okay, let's click a dog on, for example, dog 10. Yeah, this is a picture of a dog. Okay. After importing TensorFlow, the next step is, as I said before, these are just pictures. We have to transform these pictures into the pixels. Okay. For these purposes, we can find out very useful tools in TensorFlow library, which already includes an algorithm which also transform these pictures into the numbers. Just we need to do is just import them and use them. Just very simple. What I will import for this purpose is, let's click on it. If you Google on and write image data generator, this is a very good function for image data generator, which generates data from images, which generates matrices from or pixels from images. Okay, we can find out in TensorFlow under the Keras library, under the preprocessing library, which we can find many good functions in order to preprocess our data. Okay, and it is also divided into several sections. Because it's an image problem, we will find that one under the image sublibrary, and this is our function. Okay, let's copy that one or all of them. Let's copy. Let's come to our. Okay, I will just copy here. What I will say is from TensorFlow, we can say, or TF. We can see also TF because we have an alias for it, from TensorFlow.keras that image. We will import that one, image generator. Okay, let's run that one. So there is no problem. Let's add another coding section here. This will generate images. This will generate pixels from the images. If you work with convolutional neural network, you have to import this library. You have to learn this library. Let's go to the documentation of this one. In the documentation section, we always find out some examples. As you can see, examples. It will explain the parameter inside this function, and you will always find out some example use of it. So why not? I will not use that. So I will just, in order to this is trained data generator, which means it will generate pixels or matrices for our training data set. Okay, so I'm just copying that one. Let's paste here. Of course, I will customize it, but let's copy and paste here. I will also, as you can see, train generator. I will also copy and paste that one into my coding. Okay. When we work with coding, we have to use other ones work or from utilization from the documentation. There is no need to discover the United States again. So there are always many developers do the same thing. No one creates its own code from zero. Okay, just I will some customize my data. This image data generator is this function I have imported from this library. Okay, this is just the name of the a variable you can give. This is simple train data generator variable. Okay, rescale means it will scale images from 1 to 255. Okay, and these are some, I will not touch this one. These are very default variables. And what I will do is, as you can see in the second one, train generator, I will change this one variable name. Let's say this one train set. Okay. It will use train generator object. Okay. And flow from the directory. It will get the data from the directory, which so I have to specify which directory I have to work with. Okay, so I know that because this is a training data set, I want to transform my training data set. So I am going to the training data set. Okay, let's go training data set. No need for that. Let's copy path file of this file and let's paste here. Not that one. Where is it? Let's copy here. And under this is doccat folder. From doccat folder, I know that my training set here. And under training set, there is another training set option here. Okay. So I will say training set again. Yes, target size. This is very important. I work on it. You have to, which means what kind of how many matrices you want to produce. Okay, so I will use, instead of 155, I will use 64 by 64 matrices here. Base size is by default 32, which means the algorithm will in every 32 epochs it will calculate gradient descent and go back by back propagation and adjust the weight and biases. This is what batch size means. Instead of every single epoch, it will go in every 32 epochs, we can say. Okay. Class mode binary, because we have a binary classification problem, so I will not change this one. Okay, I think it will work. Let's run this code. Yes, it shows that the code has found this 8005 images belonging to classes, which is very good for us because in training set we know that we have two classes, dogs and cats. So it now our data has been transformed into the images by train generator variable object, and after that by using this train data gen object, I will get all the data from flow by using flow from directory method from this directory, and it will be after transformation it will be assigned into the train set variable. So I can use train set variable. So I will do the same things for also test set. Let's come here. Let's use test generator. Yes, test generator here. I will just simply copy that one. Now we are doing the same operation into the test set. Okay. We are using image data generator function here. We are creating a test generator variable or object here. We are scaling our pictures into from 1 to 255 according to their colors. The computer will do this job, or this image generator will do this job automatically. So let's copy the other one. This is we have created our generator. Now we need our transformation. Okay, we can just copy from the previous one, from training data set, because it is similar. Let's copy training set. I will change the name from training set to test set. Okay, we will not use training data generator variable. We have copied. We will use test generator variable here, or object. Flow from directory, we have to change this one because we will transform now our test set. Okay, so let's copy that one here. Instead of training set, we have to transform. Let's copy from the file and paste it here. Okay, we have to, we can write our hands, it's not important. Test set under dog, cat dogs folder, we have a test set, and now writing test set. Until test set, there is another test set sub library, sub folder, test set. Yes, I will not change target size because it has to match. If I select the target size 64, I have to select the same things here. It's also a binary classification problem. Let's run this code. I hope it will work. Yes, as you can see, we got different size of images. Now we have 2023 images from our test set belonging to two classes, which means belonging to either cats or dogs. Yes, let's add another code. So we are ready with transformation our data. So we can we have transformed all the images into the number or matrices by using this one. We have utilized the examples from the documentation of this image data generator library. So the next step is, after this one, let's look at, I will show here what we are here, cancel. Now we are here. We have transformed our input into the matrices or pixels, and now we have to build up our convolutional layer. Okay, so the next step is building up a convolutional layer here. Basically, we have to import from TensorFlow. We will also use the same layer here, model here. I'm sorry, from TensorFlow.keras.models. because now we are writing our model. What kind of model we want to create in our convolutional networks? Import sequential. It's a sequential model because it follows sequence by sequence. First input layer, convolution layer, multiple layer, flattening layer, and after that fully connected artificial neural network layer, and after that output layer. Therefore, we have to use sequential model here. Let's run this code, and later on, what we need to do is just create an instance or an object of this class. Okay, I will name this class this object CNN, representing convolutional network, and simply I will write sequential, which means that all the feature from this class has been inherited into this object. So I can easily use CNN variable or object, and I can utilize all the features or functions inside this sequential class. Okay. So in order to now we will create we have created our model. It will be a convolutional sequential model. Now we will build up step by step our layers. Okay, the first layer is convolutional layer. So we will create convolution layer here from also let's copy this one instead of writing every time. From TensorFlow.keras, instead of models, we will import layers. From layers, import convolutional layer. Yes, if you click on the tab button, we can see several options here. Because images we have two-dimensional, we will import convolutional 2D option here. Okay, if we got one-dimensional, we will use that one. If we have three-dimensional, we will use this one. But we will use that one, convolutional 2D class. Let's run this code. Okay, now we have imported our layer. The next step is, after importing our layer, we have to insert this layer into our sequential network. Okay, so let's insert it. How we can insert? I will just use this CNN object here and use add. It's very similar from previous tutorial. We will add now layers. If we want to add layer, we will use add function. And what we will add, con2d, con2d, yes. This con2d function has some parameters. One of them is filters. It's very important. As I said before, the also algorithm will detect the images from their features. These filters represent the number of features that we want from the algorithm to focus on. And you can try several filters here. How many different features do you want that algorithm focus on? Okay, so you can play on this one when you work on it. Because I use target size 4064, I'm just saying I will just try 32 features, basic features that I want from the algorithm to focus on. Okay, so I have used several ones, so it's not so important. You can try whichever gives you the best performance. You can select on it. And filters number 32 gave very good results. Kernel size is 3, because we have to predict 3 colors. Okay, red, green, and blue. So candle side represent three colors. If we have the black and white pictures, we will say here 2 instead of 3. And activation function, I said before, we will use relu function here. For convolutional layer, we basically use relu function. Maybe it is written, yes, activation function is relu function is used. So we basically use activation parameter in order to represent activation function, and in quotation marks we write relu function name. And an input shape, this is very important because we will say the algorithm that the shape of our inputs by using this parameter. Our input shape is 40, 64, 64, right? You can see target size or change size. We have assigned here. If we, for example, assigned 100, 100, we have to write here 100, 100 because this is the input shape. This generates our input shape, matrix size, and so we have to write here input shape parameter. Inside input shape parameter, the size of our matrices. Okay, so because it is also 3 colors, so I will add 3 here, which represents, let me show you this one, because we will use blue, green, and the red one. So in addition to do the size of the matrices, I will say that produce 3 different versions of it, because which is represented by 3 main colors as red, yellow, and blue. Yes, let's now we are the next step is coming to the next step. We have created one step of our convolutional layer. The next step is we have to simplify this this one into very simple version by using max pool function. Okay. We can basically say that it is a dimensional reduction. We will reduce the dimension of our matrices from our inputs into the very into the very simplified version dimension in order to make calculation efficiently in the future. So in max pooling section here, layer here, this max pool, we will import this one from TensorFlow. This will get the most important features from the matrices of this convolutional layer. Okay, instead of using all the features, but the most efficient, the most important one. As you can see, for example, in order to detect this animal, instead of focusing on every pixel here, we can focus on the most important one. For example, eyes, or nose, or mouth, right? For train, we can focus on some of the important ones instead of not focusing on every details inside this image. So therefore, we use this max pooling in order to focus the algorithm the most important features, not all the features in the image. Okay, let's import this pooling. We will import from TensorFlow.keras. Let's copy here and paste it. Not that one. TensorFlow. That layers. Yes, import. As you know, it is also a layer, so we will import from the layers max pool 2-dimensional, because we are working 2-dimensional convolutional network, so we need to import 2-dimensional max pooling. Okay, so I will show you something. This is the what max pooling does. This is the matrix from our convolutional layer. Okay, the size is very big. The max pooling is simplified that one into this this very simplified version. How does it do? For example, in the first pixel, it takes the maximum value. The maximum value is 20, as you can see here. So instead of all these 4 pixels, it takes just 1 pixel in order to represent these 4 pixels, which means that this feature is the basic one, is the most important one. So the max pooling get that one here. And coming for the next 4 pixels, as you can see, the maximum value is 30, and it takes 30 instead of taking into account into mathematical operation for all these pixels. And comes to the third one, the maximum value is 112, so it takes 112. For the next one is 37, it takes 37. Okay, so it's just simplified by taking the most significant features of the image. There is 2 pooling in TensorFlow. The other one is average pooling. In average pooling, we take the average of each these 4 pixels. Okay, for example, for the first one, the average is 13, and it takes 13. For this one, 32 divided by 4 is 8, so it takes it. So it is also the case for the other ones. Okay, so it's up to you. We can also choose average pooling, but I want the algorithm to focus on the most important one instead of taking average. You can try on it. So this is what max pooling does. Just simplifying. It is just dimensional reduction. Okay, instead of using this 4 by 4 dimension, we are using 2 by 2 dimension matrices by just focusing on the most important features of the image. Okay, therefore we need max pooling. We are using max pooling. You cannot use, if you want, you don't use, but it will take to train the algorithm very long time, or sometimes the algorithm can focus on some unnecessary features, as for example in the train picture, there are, as you can see, there are buildings here, there are training platform here. We should focus on all the features, just focus on the important ones, what I want from the max pooling. Yes. Let's go down. How can I add this one into my convolutional network? TNN.add method function. Okay, I'm just adding this max pool 3-dimensional. I'm sorry, 2-dimensional, and after that, 2 important parameters here. One of them is pool size. I will explain what does it mean. I will select 2, and also strides is 2. Let's turn back to our picture. Pool size, which means 2 by 2 matrix, what I want from the pool size. I'm sorry. Pool size means, for example, how many steps I want to go inside the pixels. Okay, so I have 64 6 by 64 matrix for each picture. So by pool size, it will go, I assign 2. If I assign 1, it will go pixel by pixel. For example, from that pixel, go to that pixel, go to the next pixel, step 1 by 1. Because I assigned 2, it will go 2 pixel by 2 pixel. First, that one, it will take these 2 by 2 matrices here, and go to the next one here, go to the next one here. Okay, this is the this by using this pool size parameter, I inform max pooling that go 2 by 2 in every 2 pixel, go to the next pixel. Okay, this is the possibility I can use. If I say 3, it will go to the 3, take the 3 one at the step 3 step, jumping 3 step, and go to the next 3 one. Okay, it's up to you. As in some cases, 2 by 2 in main approximately works better, I think. And this is the max pooling size. Okay, and the strides means number of matrices I want. I want 2 by 2 matrices. Okay, 2 pixel and 2 pixel. If I selected 3, it will go 3 by 3. So it has to match. If you select, for example, pool size as 3, also I think you have to also choose the stride as 3. So for simplification, I think pool size 2 and stride size is 2 is okay. Okay, so I'm just clicking and adding this layer. Now, as you can see, let's go up. Where is my neural network? Yes, here. Now I have added one single convolutional layer. Okay, and I simplified that one by using max pool layer. Okay, so you can work. I think our convolutional layer and max pool layer is ready, but you can add more convolutional layer and more by default also more pooling layer in order to simplify that one. So I will add another convolutional layer. You can use 1, 2, 3. It is up to you what kind of data you have. I tried. So let's use that. Let's add another one. I will not change anything. Okay. Now I am adding another convolutional line, and so I have to add another max pooling in order to make that one simplified. Okay, let's go to our picture again. Now we are ready. We have added 2 convolutional layer, I'm sorry, and 2 max pool layer in order to simplify that, in order to make a dimensionality reduction in machine learning phrase. So the next layer is flattening layer, which means that instead of using 2 by 2 matrices, I will simplify it and use by one-dimensional matrix in order to make mathematical operation very simple, in order to train my algorithm in a short time. You will now later see that this will take a lot of time to train this convolutional neural network. Let's add it, but before we add, we have to import this flatten object from layers, because it's also represented by layers. So I will find that one, layers, import flatten. Let's tab it. Yes, it comes automatically, which means that there is only one class by beginning by F. Okay, it's very simple. We will do the same thing. We will add. This is my CNN neural network. Okay, sequential model. I will add this sequential model another layer, which is flatten layer. Let's add it by using add function. I will use flatten. I will not add any parameter. This one we don't need it, because it will just simply transform what we feed them into one-dimensional matrix. Okay, let's run this code. Now the next step is to create our fully connected layer. Okay, this means that we are ready transforming our images into matrices. We have created our convolutional layers. We have flattened them. We have used max pooling. And now the next step is using normal artificial neural networks to train the weights and biases. Okay. So all the phases to this point is related to just convolutional neural networks. The next step is very similar to how we train the normal artificial neural networks. Okay. So as you can remember from previous tutorial, we will add here dense layers, okay, which represent artificial neural network, densely connected neurons. Now we will add neurons. Okay, let's copy that one here because I will find that one from layer class and import layers library. I'm sorry, import dense class. Okay, so cnn.add the same thing. Now I am adding this densely connected neurons inside my convolutional neural network. Okay, I'm now adding dense layer. Dense. Inside this dense layer, as you can remember, we have to specify number of the neurons, which is assigned by units parameter. How many neurons I want? Because I use filters 32, which represent my basic important features from my pictures or images, I will use 22 neurons first. You can also begin. Let's try that one. We have used 40. Let's begin from the highest one. We have used 64 times 64 matrices. We begin with from our input layer. Let's begin with it is 2 times higher. This 100, that one, 128, and after that I have to use my activation parameter because I have to assign how the mathematical operation will go from one neural one neuron to another neuron. I'm sorry. Okay, we will use also ReLU. Okay, what happened? Activation. I'm sorry. This is I need another one here. This is just now we have added. Now we can add another one. Let's add that one. I mainly use half part of the previous layer. It works generally. We can add another one. I think that's enough for us. Okay. Now we have also added. Let's come to our image. We have added two fully connected artificial neural networks. Okay. So by using dense class. So the next step is creating our output layer. We are almost about to finish our convolutional neural network. So let's add it. cnn.add dense. We will use dense number of units. I will assign 1 because we will predict either cat or dog, right? So I will just assign 1 number of units. This is my output layer, so it has to match with my target. or my target categorization. It's a binary categorization, so it will predict either 0 and 1. So number of units or number of neurons is just 1. So we will also add our activation function. We have to use sigmoid because it's a binary classification problem. From this point, the neural networks may be any kind of number, okay? But when it comes to output layer, I have to now determine what the result should be. The result should be either 0 and 1. Which function gives me this result? This Sigmoid function. If you feed Sigmoid function any value from minus 1 trillion to plus 1 trillion, the result will be a value between 0 and 1. Okay, therefore, which means that either cat or dog, which is very suitable for classification problems. So I am using this is the reason why I'm using a different activation function in my final output layer. If we have to produce more than one classes, for example, zebras, elephants, cats, dogs. So we have to use softmax function because it is very useful for multi-classification problems. In binary classification function problems, whatever machine learning algorithm you use in deep learning, you have to use sigmoid function as for your output layer. Okay, let's edit. Now the next step is we have now built up our own network. Okay, we have created. Let's see our picture. We have created our convolutional neural network, convolution layer. I'm sorry. And max pool layer, and after that flatten layer. Now two fully connected hidden layers and one output layer. Now we have built it up. The next step is we have to compile how we will adjust weights and biases in order to find out bad predictions. Okay. We will use just CNN. It's very simple in Python. We will just use compile. Maybe you will remember from previous tutorials. We have to specify our gradient descent, which is very important because it will assign by using optimizer parameter. I will now assign what kind of gradient descent algorithm or function I will use. Mainly we use Adams. It works better compared to other ones. Or not optimizer. Yes. So we have to specify our loss function by assigning loss parameter. For binary classification problem, we are using binary cross entropy. I hope I couldn't write. Yes, cross entropy. And in order to see the results, I will use a matrix which means accuracy. In order to see the performance of my algorithm, I will use matrix. This is not necessary, but when in the training phase, by using matrix parameter, I can easily see the performance of my algorithm. Okay, epoch by epoch. So therefore, I am also adding matrix. Let's run that one. I think there is a problem. Can compile binary cross entropy, maybe binary cross entropy accuracy, matrix accuracy. Yes. I'm sorry, not Adams. Adam. Yes. Now we have solved the problem. Now we can now fit our data. Okay. We will use you will remember the same thing. Fit function. Our x are represented by our train set, right? Train set. So we say train set, right? Here, yes, train set. So which represent my x, and my target is. So I will not use a target, but I will use a validation data in order to compare the result. I will use validation set here. The algorithm will just compare the result, not take into account the information from the test set. Okay, so I will just use test set here, and let's epochs. Let's assign 15. In convolutional networks, it takes a lot of time, so we have to begin with very smaller size of epochs. It will not work. We can increase, of course. Let's find it. Is there any wrong? Validation set. Not validation set, validation data. I misspelled parameter name. Yes, now our convolutional network is training, as you can see here. I think it will take some time. As you can see, it is very, very slow compared to other neural networks training process. We have now in the beginning of the first epoch, it will take maybe 2 or 5 minutes. Do you have any question to this point?
No, I don't think so.
Okay. Do you find the informational reasonable, or is it, or will it sound difficult, or easy, or medium? How do you find it?
I think it's pretty okay. Like the way of implementing it seems pretty straightforward.
Yes, I mainly try to simplify it because if we learn the simplified version of it, we can easily understand the complicated usage of it. Okay, in our data we have just 2 categories: cats or dogs. So it's very simple data, but in very complicated data sets, we will have to make much more adjustment. But whatever you make adjustment, the working architecture lies in this picture. We have inputs and we will get outputs. We will before we get the inputs, after we getting these inputs, because this is pictures, we have to transform these pictures into the matrices, right? We have used a specific function that is determined in TensorFlow. And after that, we have, after transforming these images into the pixels or matrices, we use a convolutional layer. Convolution layer, and which means that we assign our what kinds of properties we want from the images. And after that, we use max pool layer. We simplify the previously determined matrices into very simplified matrices. And instead of taking all the features in this process, in this layer, we get the very important features. So after that, we transform that one into the one-dimensional matrices in the flattening layer, and then we create our normal neural networks, which means we add normal fully connected neurons. For example, recurrent neural networks or normal artificial neural networks, there is no need to be use fully connected layers, okay? But in this convolutional neural network, it is necessary. We have to use fully connected, which means that all the neurons should be connected to other neurons. This is a necessary step, also important. But the other two, artificial neural network, there is no necessity for this. You can use it, but you cannot. Also, you can choose to not to use it. Okay, and then we create our output layer, and then we compile all of these layers by using that CNN.compile function. And in this compile process, we assign what kind of gradient descent type we will use, what kind of error function we will use. Let's calm down. Not here. Error function or loss function we will use. It depends on what kind of data we have. And then we train our data by using fit method. We train, and after that we will use predict method or predict function in order to predict the data we have not seen. We have not trained our algorithm. You can use test set for this purpose, or you can use, for example, we can choose either cat or dog from the internet and use it in order to evaluate the performance of our convolutional neural network. I think we can get 2 or 3 minutes pause, because I think it will take time. As you can see, sometimes it takes 10 minutes, or yes, approximately it will take 10 minutes. We can get 5 minutes break until the algorithm is ready for training, and after that we will just make our predictions from our test set, or we will import from any cat or dog from Google. And so we will very practically use, we will learn the use of how we use convolutional neural networks very straightforwardly, and in very real case. It is not an artificial data, it's a very normal data set. So in the other options, when you learn or study in the future, when you work with this kind of data, you will encounter very similar cases. So it's a very good starting point, I think, to begin to work with convolutional neural network. Let's take 5 minutes break. If you don't want to wait, if you say that, okay, these results are enough for me, I don't want to see the predictions of the algorithm, you can just finish the tutorial here. It's up to you. But if you want to see the results, we have to wait this one. We have time. We have almost 15 minutes, so we have enough time. It is up to you. It's not compulsory. We can take 5 minutes break if you want to see the results, or we can finish this one, and I will download, of course, this tutorial and send from Discord, and also I will also send this video and share in Canvas. What do you think? Shall we take a break 5 minutes, or do you want to just end this tutorial? It's up to you. I will combine you.
I think it's fine to wait 5 minutes, and then maybe we get pretty good results. That will be a little exciting.
Okay. Then we will take 5 minutes. I will stop this recording. Yes, it takes time to train convolutional neural networks. We are almost ready. I think we are 14th epoch now. And basically you can work on the number of layers and something, and now it seems that the accuracy is very close to 80%. It's fair. It's fair, I think, as well. But if you adjust the variables, parameters, and biases, number of layers, hidden layers, very good, you can get very good results in deep learning. For example, in the deep learning project assignment 2, I used normal Python code to train the algorithm. For the testing set, I got 100% accuracy. That's right, 100%. It is almost impossible to get this result for normal machine learning algorithms, but I got it. Because if you adjust the variables and parameters and number of layers, hidden layers, and etc., you can get very good results. And actually, we can also increase the accuracy of this convolutional neural network, but I couldn't do it because the exams are very close, and training takes a lot of time, as you can see here. So, but it's possible to try to work with the parameters and something in order to get better results. And we are very close to, at the end of the 15 epoch, we are very close to 80%. It's fair, I think. Yes, because we don't have enough time, instead of writing coding step by step, now the next step is, after training, is to just making predictions in order to test how work our algorithm is. I will just simply, I created a predictor previously, predictor function, my own function here. In order to make predictions, it will not get the normal photos or images automatically. We have to transform them, right? In order to transform them, I just use from TensorFlow. Let's copy that one here. From TensorFlow chaos preprocessing, that from import image class. And inside this image class, I will use load image function. As you can see, image.load image function. This is location is the target location of my file, dog or cat. Okay. By using load image, I will load that image into this test image variable name that I assigned. This target size should be 64 by 64, because if you can remember, we have assigned our target size 64 by 64. It has to match with this one in order to get good better predictions. Okay, and after that, after loading as 64 by 64 matrices, I'm using the same library, image to array function. This will transform the images into the arrays. Okay, after loading these images from the location we will assign later, we will load into the test image variable here, and after that we will transform this test image into the arrays or matrices. Okay. The next step is by using NumPy expand dimensions, because we have to expand the dimensions of this image. We will import as the images our test image. Okay, and later on we will make our predictions. So we will insert the final result of the image and make our prediction, and this result will be the prediction of our trained convolutional network algorithm. And I'm now making a if statement here. If result 0, 0 by, it will 2D dimensional, so I will get from the 0 element of the 0 index from the result, and if it is 1, it is a prediction is dog. because the algorithm will evaluate dogs as 1 and cats as 0. I know beforehand, and after that, if it is 0, else if it is 0, it is a cat. And finally, I will return my prediction. Okay. Yes, prediction is here. This is another variable here. Now let's run that one. Let's code it. What we will do is just let's assign a location variable. Okay, and after that I will use my predictor function and assign location variable inside this prediction, and it will produce me after these steps final result. Okay, and this is a good, this function works, I think, every kind of image pre-processing. And location, I will assign location from here. Let's import a data. For example, let's import a cat. Okay. Your data set. Yeah, I know there are cats or dogs from my dogs. Okay, we can just import from, let's see, dog. Let's import from here some fine dog images, right? I will save this image as dog. Say that one from my desktop. After that, I will upload this image into my Kaggle account. Let's find a cat. Okay. Let's split fine. Let's save image as cat into desktop. Okay, so I will just add this what I download. So we are working instantly, so there is no anything I have done before. As you can see, I am doing now upload section, browse files from desktop. First of all, I will upload to cat. I have to name it. Let's say this one, cat image. Okay, let's create that one. And now it is uploading. Success. Let's upload the other one from my computer. Let's browse it. Let's upload dog image also. Let's say that one and dog image, and it can be public. Let's create it. Now I have uploaded here, whatever location you can choose. Inside cat image, as you can see, I have the file. Let's copy file path because I need into my location variable. But it should be inside quotation mark, right? Let's run code. What's wrong? I'm sorry, not training set. This should be train set. Let's use another one. It's not predicted good. Let's upload the dog image, right? Copy that one. Okay, so we have to change this location. This is as we can see from the validation data, the accuracy rate is 80%. So it doesn't mean that every time. Now it predicted good for the dog, for example. It doesn't mean that 100% it predict well. Let's create another image. Image, for example, let's add data. It should be from my data set. Cat image, dog image. Okay, single cat. Yeah, let's add this one. Let's add another one from my data set. Single dog, yes, that one. Okay, we will make more predictions now. Let's use this. I will just change location, path of the location. Where are they? A single dog. Let's click on and copy the file pathway and paste it. Delete this one, previous one, and this is the location. It will assign into my function and give the results to me. Yes, it's a dog. It's predicted good. Let's click on the image. Yes. And this is a dog, as you can see, and the algorithm predicted as dog. Fine. Let's try another one. Let's copy this one here. Yes, we have also imported another single cat. Let's copy path file and paste here. Yes, it's predicted good. It's a cat, right? So I think yes, it's a cat, as you can see. We tried 4 options. The performance according to validation data, it was 80%. Out of 4 prediction, it predicted 3 of them very accurately, right? So we have to be very cautious about the final result. Maybe 20% maybe fail, as we tested in the first one. Let's look at this one. Come to my cat. Maybe this image was very small, and this is the reason. Because as you can see in this image, it's very small. Let's look at the other one. It's also small, but it predicted that one true, that one false. It's normal. As I said, we can train, we can adjust the parameters in order to get more higher accuracy. It is up to us. It's up to how much time we have. So out of 4, we predicted 3 of them true. We can try and add more cat and dog, and I think approximately the algorithm will provide us 80% right accuracy. Okay, and there is a risk of 20%, but in normal machine learning algorithm, 80% is pretty good result. Even though we didn't create a very complicated algorithm, we didn't. I just tried several times. We can adjust a couple of things. For example, let's come here. Maybe change the number of units, neurons here, or maybe we can add more layers, or maybe we can increase the filters, number of features we have to focus on, right? I can do this now, but as you can see, it takes a lot of time. But you can adjust yourself. I will download this entire tutorial file, coding file into this Discord, my Discord announcement section, and you can read. Okay, this is all from me. I hope it is good, and it's good representation